All right, we're now ready for lesson 1-5, and our title today is Angle Relationships. And we want you to leave today with two major objectives to understand. Identify and use special pairs of angles, and we're going to get some terminology down in just a minute involving special pairs of angles. And then later on we'll talk about perpendicular lines. So let's just jump right into some definitions and examples. So adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior point. So I gave you a couple examples here. Notice that these two angles, 1 and 2, share a common side, but the interior points, that would mean like points like this, these are interior points for angle 2. These would be interior points for angle 1. And so no common interior points between those two angles. And so here's another example. Notice they share the same vertex. They share a common side, but they do not share interior points. And then we have a linear pair of angles. A pair of adjacent angles with non-common sides. Now, what that's talking about here, the non-common sides that are opposite rays. Okay, and that's talking about these two sides right here. So you'll be able to identify what is known as a linear pair because you're going to see a pair of opposite rays. So you'll notice that they really don't share that side between the two angles, but if you notice that between the two rays included with the two angles are two opposite rays, then you know that you're dealing with what is known as a linear pair. Okay, vertical angles, two non-adjacent angles formed by two intersecting lines. Okay, so here we have two different pairs of angles. So we could say angle 1 and angle 3 are vertical. And then we have another pair, angle 2 and angle 4 are also vertical. And then we'll go ahead and make one more statement. Something that's always true about vertical lines is those opposite angles that are created, like 1 and 3, 2 and 4. We could make another statement that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So vertical angles create congruent angles with these ones that are opposite each other. And that'll be important for problems that we do in this lesson in the homework assignment. Okay, complementary angles, two angles that add together to equal 90 degrees. And so here are a couple of examples, angles 1 and 2 in this picture. You can tell this is the symbol for 90 degrees. So if you add those two together, they come to exactly 90. And then here's another example. Just because these two angles are not adjacent, it doesn't mean they can't be complementary. We could say that angle A is complementary to B or vice versa, as long as the two angles add together to equal 90 degrees. And then supplementary angles, two angles with measures that add up to 180 degrees. So a couple of examples, 3 and 4. Notice if you put these two angle measurements together, you have these opposite rays, which means it's a line, and lines measure to 180 degrees. And then same thing up here, just because they're not adjacent angles doesn't mean they can't be supplementary to each other. Okay, widen my screen here just a little bit. Now we talk about perpendicular lines. These can be lines, segments, or rays that intersect to form right angles, or right means 90 degrees, of course. And then a couple other statements here that just to further enhance that definition. Segments and rays can be perpendicular to lines. It doesn't have to be two lines. It could be a ray and a line, or a segment and a line, as long as the intersection creates a right angle. The right angle symbol in the figure indicates that these lines are perpendicular. So the symbol for perpendicular is going to look like this. And literally, if we were reading that into words, it would mean is perpendicular to. Perpendicular to the U in there. And so using my example here, I could say line AD is perpendicular to line BC, for example, because they intersect at a 90 degree, or they create a 90 degree angle when they intersect. Okay, so that takes care of terms. Let's do some examples like your assignment to get you ready for this, and then of course I'll have a homework help video that hopefully is there if you need it. So let's take a look just applying some of these terms, and in some cases we're going to be reviewing terms that we've learned in past lessons. So the directions tell us to name an angle or an angle pair that satisfies each condition. So for letter A, two acute vertical angles. Okay, so remember, vertical angles are angles that really are opposite each other. They share a vertex, but they open in opposite directions from each other. So acute means less than 90 degrees, of course, between 0 and 90. So I see a pair of acute vertical angles right here. I'll just highlight. This has to be less than 90 because that 90 degree symbol goes all the way down to FKJ. So I just highlighted this other angle, which has to be less than 90, and it is vertical with this. They share the same vertex. All right, and so we could say angle FKG and angle EKH. All right, so I'll erase that so we can look at our figure again. Okay, now let's name two obtuse vertical angles. So obtuse, of course, means between 90 and 180, greater than 90, less than 180. And so I notice up here that we have an obtuse angle, EKF, and that is vertical with the other angle that opens opposite it, which would be right here. So we could say EKF and HKG. And so you might be wondering, well, how did you know for sure that that was obtuse? Well, one way you can know is this EKG is a line, all right, and we've already established that this, of course, would be 180 degrees. This 90 degree angle means that this has to be less than 90 right in here. So let's just put some numbers in here just to kind of make this make more sense. This is the 90 degree, okay? So whatever this is right here, FKG has to be less than 90 degrees. So let's just say it's 80 degrees. That means that this, because if this EKG has to come up to 180 degrees, then this would have to be something like 100 degrees. So just as an example. So that's how you can tell that EKF is obtuse. And these angles opposite, they're intersecting lines basically that share the same vertex. And so that makes them vertical. All right, name a linear pair. A linear pair. You should be looking for opposite rays basically on the bottom of each angle. So here's an example of a linear pair. We could say HKE, and then you could say FKE. HKE and FKE. Right. Two acute adjacent angles. Okay. Two angles that share the same side, same vertex, common side, but they would be less than 90 degrees. All right, so let's see if we can identify where those would be. All right, so going back to this angle we looked at earlier, FKG is less than 90, and it's adjacent to GKJ. Let's go to a different color. GKJ is also less than 90. So those are two acute angles. That means they're both less than 90 degrees, but they are adjacent. So FKG, GKJ. Okay. Name an angle that is complementary to EKH. All right, so let's just highlight EKH. Okay, well, if you recall, complementary, of course, means that they have to add up to 90 degrees. Well, one way of looking at this is EKH is a vertical angle with FKG, which means they have the same measurement. They are congruent. So over here we notice that this angle and this angle together make a right angle. So these are complements. Well, if GKJ is complementary to this FKG, then it also has to be complementary over here because these are the same measurement. So we could say that angle GKJ is the complement. Remember, they don't have to be adjacent to be complementary or supplementary. Okay, clean this up a little bit, and then we got one more of these. So name an angle that is supplementary to FKG. FKG. Well, yeah, we have choices here actually. We could go with EKF because together those would represent the sum of 180 degrees. So I will say EKF. And you could also, if you wanted to, you could say GKH. That would work as well. But you just need one answer. But either one of those would be correct. Okay, that takes care of those examples. So your homework will involve just turning to your homework page. Looks like problems 8 through 17 will look like this type of activity on your homework page. Okay, and then when you get down to problems 19 to 24, you'll be doing problems like this. So find the value of each variable, finding x and y. So I'm going to find x first because we see that we have a pair of vertical angles here and here. These are vertical. These are intersecting lines. These two angles share the same vertex. They're across from each other, diagonally or opposite each other is a better word. So since they are vertical angles, that means they're congruent, which obviously means they equal each other. So we can find x by setting up this equation. Solve for x. So if I subtract 2x and if I add 10, I got my solution for x. X is 35. And now I'm going to use the principle that these two angles are supplementary so that I can find out what y is. So I can replace x here with 35. Add that to y, and that should come up to 180 degrees, the definition of supplementary angles. So this is 70 plus 25 plus y. This is 95. And so when you subtract 180 minus 95, you get 85. So those are my two answers for the variables. X is 35 and y is 85. All right, and then letter B. Let's see how we can attack this one. We have vertical angles again. So just to illustrate, this angle is vertical with this one, which means they are congruent. So I can set 5x plus 4 equal to 114. 5x is equal to 110. So x is going to be 22. All right, clean this up a little bit. And now let's see how we can go about finding y. So using, again, the idea of supplementary angles, here I have a pair of angles, actually 3 different angles together that need to add up to 180 degrees. Okay, so here is my pair of opposite rays, that equals 180. So if I take, if I substitute 22 here, 22 here, and then I've got this little pi piece that is called 2y, I'll let all 3 of those added together equal 180 degrees, and that will help me solve for y. Okay, so I'll just show my work like this. 5 times 22 plus 4, okay, that's this piece, this angle. 3 times 22 minus 24, this angle. And then this small angle here currently is known as 2y. But all of that, all 3 of those angles should add up to 180 degrees. So this is 110 plus 4. This is 66 minus 24. So we'll add all these numbers up. If you want to grab a calculator. So 114 plus 66 minus 24 is 156. So 180 minus 156 should be 24. 2y is 24. So y is 12. So we got our values of the variables. X is 22 and y is 12. Okay, and so it looks like you've got a set of 6 problems like that. in on that page 51. So hopefully this will help, or refer to the homework help video. And then two more, and this will wrap up this lesson video. And these problems start with number 25 and go through number 28. So letter A says, find the measures of an angle and its complement if one angle measures 24 degrees more than the other. So the way I'm going to represent an angle and its complement is, first of all, I'll just let X represent an angle, one of the angles. So since they're complementary, I can let the complement be 90 minus X. So you can kind of reason through this. If X is 20, for example, if I just let that be a real number, then the complement has to be 70. These two together, of course, have to be add up to 90. So if I know what an angle is to find the complement, I just do 90 minus that number. So these two angles differ by 24 degrees. Another way you can look at it. They are different by 24 degrees. That sounds like subtraction. So if I take an angle and I subtract its complement, the result, in this case, according to this, should be 24. And so now I just solve for X. So this is really X minus 90 minus negative X. Remember, we're just going to distribute negative 1. So that makes plus X equals 24. 2X minus 90 is equal to 24. 2X is equal to 114. And X is equal to 57. Okay, so that's the angle. And so what is the complement? So 90 minus 57 is 33. And so just a little help in solving these word problems. Now sometimes you'll see an angle and its supplement. Well, in this case, if that were true, then of course we would have changed this to 180 minus X. And we could have gotten our answer that way. Okay, letter B. Once again, two angles are complementary. This one's a little different because we're told that the measure of one angle is 21 more than twice the measure of the other angle. So I want you to pick a variable to represent an angle of these two of this pair. So I'm going to let X equal an angle. And according to this, I'm just going to use these words, this sentence, to represent the other angle, the complement. Okay, the measure of one is 21 more than twice the other. And the way I represent that in math is 2x plus 21, and that's going to be the complement. And now I'm just going to use the truth that two complementary angles added together have to equal 190 degrees. Sorry. I'll solve for x. X plus 2x. 3x is equal to 69. X is equal to 23. Sorry, 23. So that's the angle in our problem. And so the complement will be found just by plugging x in here. So 2 times 23 is 46 plus 21, and that's 67. So the two angles that we're looking for, one angle is 23 and the other is 67 degrees. Okay, well, that's our lesson 1-5 overview, and hopefully you're ready to do the homework problems. Refer to the homework help video if needed, and if you have any questions, let me know.